This part will be a longer one, and here we write as a core part of the game. And we'll start with utils. And first, we create functions that convert radians to degrees and degrees to radians. We are accustomed to think in terms of degrees, so we'll pass to different functions degrees, but then internally these degrees will be converted to radians. After we're done with these converters, we create two utils functions. First, we'll receive an array and element we don't need. So then we'll apply filter method and return a new version of array without given element. So we won't mutate an existing array. And the second function return array with updated element. Here we receive an array, old element, and the new element. Then we apply map function and we check if element we receive is equal to old element, and if this is the case, we return new element. Otherwise, element we received as parameter. Next, let's go to the vector class. First, we import our newly created functions from utils, since we will need them to work with angles. And the first method is subtract. It works the same way as add, but here we subtract vectors components one from another. And if you are not familiar with the basics vector operations, I have a good series on Medium about linear algebra, and you can in few minutes start understanding how vectors work, and it's super simple, so I'll provide a link in the description. So next is dot product. We apply linear algebra formula here. So we basically multiply components of one and another vector. Second is project on. So we will project our current vector on another vector. It includes quite a few operations called dot product and divide by length. You can see what this method does on image example. Next method is reflect. So we will use this method to bounce ball off the walls, block and pedal. So we'll pass normal. So for example, if this is a wall, normal will be pointing here, and then we will reflect from this normal vector. Here we also apply linear algebra formula to reflect. Also, we'll need to rotate our vectors. So we'll pass degrees, and first we are using our function to convert this to radians. And then we need to calculate cosinus and sinus for these radians. And finally we can return the new vector. We add some calculations here. When we are done with rotate method, we will write a cross product vector method. And the cross product is only defined for three-dimensional vectors and produces a vector that is perpendicular for both input vectors. But in two-dimensional space, we can think of cross product operation as length of resulting vector if it would be in three-dimensional space. And we need this method in order to calculate angle between two vectors. So here we are calling cross product and dot product. Next, we are ready to write the core functionality of our game. First, let's add distance in milliseconds, and it tells how far can ball and pedal go in 1 millisecond with a speed equal to 1. And for example, if we have a distance speed equal to 2, it means that in 1 millisecond we'll move not on 0.005 but in 0.01. And movement object is like a num. In other languages, it helps to reduce the probability of making typo if we pass in movement here and there. And as the same way with left, right, we need a down vector. So we create down vector 2. Next, we need get distorted direction function. And after hitting an object like ball or pedal, we want the direction of the ball to be reflected with some added distortion to make the game more interesting. And distortion will add a small random vector to the direction and then normalize the result. Here we need to generate a random number both for x and y components. So first we create a function that will do this. It will create a random number between minus 0.1 and 5 and to 0.1 and 5. And then we can create a distortion level by calling getComponent function. And at the end we add to the vector, and since result won't have the length of 1, we need to normalize it. And on every update, we'll check if the player wanted to move the paddle, and in such case, we'll calculate a new position. If it doesn't cross left and right boundaries, function will return new vector, otherwise it will return adjusted one. So here we receive pedal, size of the game, distance between old position and the new position of the vector, and movement. Movement will be left or right. So first we determine our direction, and then we take x component from a new pedal position and we calculate new position by adding direction scaled by distance. And remember that direction is always equal, length of the direction always equal to 1. It's normalized vector. And basically in all the cases we will return the old pedal but with new X components. So here we write a helper function that will return old pedal but with a new position. As we can see, we simply update X component in the vector here. So here we check if X is less than 0. And in such case, we are gone too far in the left. So position of top left corner of the pedal becomes 0. And if we're going too far on the right direction, we will return pedal with X equal to like the size of the width of the game minus pedal width. So we'll never appear far from the field. So we have a boundaries and we can't move pedal behind these boundaries. Next, you write a small function that will be used for the block ball collision detection. And we will think about ball as a square. So we basically detect a square rectangle collision in this case. And it checks if at least one side of the object inside boundaries. For example, we can pass to this function the top and bottom of the ball and block to check if the lower or upper part of the ball inside of a block. So we do check for one side and then for the other side, and we will call this function both to check if it hit from the left or right or from the top or down. And we won't escape a situation when the ball goes back and forth between walls, since it makes the game boring. And this happens when the angle between normal of the wall and direction is close to 0 or 90 or minus 90 degrees. And here we calculate angle between normal and the vector. Then we calculate max angle. In our case it will be 75 degrees. Then we check if angle is less than 0, and if it's bigger than minus 15, we rotate it to the minus minimal angle. In this case it will be minus 15. So if it was minus 3, it will become minus 15. Then we check if angle is less than minus max angle. It will be minus 75 and also rotated. And then the same check for in the case when angle is bigger than 0. The same steps. And if everything is okay, we simply return vector that was passed to this function. And finally, we are ready to write a function that will create a new state. It receives old state, movement of the pedal, and time span between last update and now. We're starting by taking size, speed and lives from the state. Then we calculate distance by multiplying time span on distance in millisecond and speed. With all this information, we can calculate a new position of the pedal and get new pedal. So we call our function pass old pedal, then size and distance, and also movement. Then we take radius from the state. We also take all direction of the ball. And with all this information, we calculate new ball center. And to do this, we do the same as we did with pedal. We add vector to the center of the ball. Then we calculate bottom position of the ball, and to do this, we add radius to the y, and don't forget that y directing down in our game. And then we check if player missed the ball. And if this is the case, we return new pedal and ball, and we reduce amount of lives. Then we declare a few functions by calling which we can return state with an updated ball. So here we can pass a few props, and function will return a new version of state with updated ball. And more often we will need to update direction of the ball. And in the most cases, we simply need to pass normal. And if ball hitting, for example, wall, normal will look like this. It will direct in this direction. If it hits the top, normal will direct at the bottom, and if the left, normal will direct at the right. So we receive distorted vector, we get new direction, and then we can call with new ball props, and here we simply pass a new direction. Then we calculate ball left, because we will reuse this variable, and we are doing this by subtracting radius from X component position. Then we're doing the same to calculate ball right, but here we add radius and ball top. So now we have all these values, and we can check if ball hits pedal. But before we do this, we also need to calculate left, right and top of the pedal. These are very simple calculations. And pedal top is simply Y component of the position. Then we want to check if ball going down. If ball going down, then we can check if it can hit pedal. But if it goes down, we don't need to check if it hits pedal. So here we check this, and we check this by calculating angle between up vector and all direction. So we can determine this, and next we need to check if ball hits the pedal. So here's like very simple collision detection going on. And if it hits the pedal, we call this new ball direction, and normal will be pointing up because ball hits the pedal, and normal for pedal will direct to the top. So we pass an up direction. And with the top, there's different situation. Normal will be pointing down. For left, normal will be pointing to the right. And if ball right is bigger than width of the game field, we update ball direction and pass left. So we checked all collision with pedal and balls, and next we need to check if ball hit some blocks. To do this, we go over each block. We take position, width, height, and we simply call our isInBoundaries function, and here we pass top button and x and y plus height. So we check if it hit one of the boundaries from the top or bottom, or cross one of the boundaries from left or right. After we calculated find block, if there was any block, we need to do some additional work. So here we reduce density of the block, and here two situations can happen. We can return blocks with a block where density is less on one unit, or we will need to remove block because there's now no density. So if density less than 0, we call our helper function, and that will return new array without element. Otherwise, we need to update element. So we call block and new block. Next, we write a function that will return new normal for block. So because we need to bounce from the block, here we need to calculate top, bottom and left for our block, and here we'll basically do the same collision checks as we did with walls. First, I will check if ball hits the block from the left or from the right. So if ball left is less than block left, we need to bounce from the left side of the block. And so we have like left side of the block, and normal also pointing to the left. So we return left, then we check if it is right. And if it's right, normal will point also to the right. So we need to reflect from the right normal. And the same simple checks for top. Top and like this. And finally, we call with new ball direction. And here we also return new blocks. If ball didn't hit any block, we call with new ball props and update ball center. So basically we are done with the core logic, and in the next part we put everything together and finish this course.